Alright, here's the part on the tombstone in the CAD software. Oh, by the way, I had a couple of questions about this ANSYS version of the software, but I still use SpaceClaim software, but apparently I hadn't paid for my maintenance agreement for many years. I'd just been using the software, but then I wanted to move it over to my new laptop computer, and in order to do that I had to kind of upgrade to the newer version of it, and apparently this ANSYS company has taken over SpaceClaim, and they were offering a special deal so I could upgrade it at a very reasonable price. So that's the reason that this says this now, although it's still SpaceClaim. Apparently they're dealing with that as well in all of their software packages. This ANSYS place makes many different kinds of softwares. So that's the reason this is showing here. Some people asked questions about that last time, but anyway, this is the fixture base plate. Let me hide the stock. That's what I call the base here, and this is the piece of plate that we're machining it out of, but we're only doing these end details here, facing it to an even thickness and doing these end details. We're leaving it thick still because we're going to finish that up when we go to the Mazak. Alright, here we are in Esprit, the same thing in Esprit. And let me run the simulation so we can get an idea of what's going to happen with the machine work. Let me slow this down a little to begin with. So here's the face milling cuts, just to bring the face of the plate from the raw face to a finished face. And then there's these 3 holes that I drill just to tie the part down a little better to this tombstone thing, so that when I do the milling on the ends it doesn't move on me, because I'm really not trusting those edge clamps. I didn't model the edge clamp things, but you'll see them in the video. And just to be safer, I put these 3 holes. This is all going to be machined away in the actual part, so it doesn't matter. I can just hold it down better. And here's the holes to bolt the end pieces to the fixture plate itself. Let me speed this up just a little bit so we can get through it. And then we're going to rough out the notches on the ends. So that's what it's doing here. Now this is that I programmed this like adaptive type cycle, or Esprit calls it a profit milling. I think Fusion calls it adaptive, and it's kind of a trochoidal roughing cycle. And although it can kind of put different cycles in the same cycle in Esprit, I'm not sure about Fusion. It can slot, it can mill profiles, and it can do the trochoidal type things. So there's that, and then there's 2 spring cuts on each end. So that's the simulation in the software, the CAM software. Face this side of the part here. I didn't show that in the video, but it just manually faced it on this piece of plate, and you can kind of see the idea with the bar and the edge clamps now. There was a few comments earlier in the first video about, well, why don't you just use vices to do that bar? And that could be done if I had the vices. I don't really have the vices to put on here, but even with vices, you can mount maybe, well, I could turn this plate the other way so the T-slots ran horizontally, and I could mount maybe 2 vices, two bigger ones, I guess, 8-inch vices, or maybe 3 littler ones if I could figure out how to tie them down. But the thing is that the bar was way out here, and you have all these gaps between the vices, and that would work, but you can't. It would be like you set up all of that just to do that one bar, and then I got to come back and put this setup in here to do these pieces of aluminum plate. So I was kind of like thinking, well, why go to all that trouble? I'll just use this bar, and I'll do the piece you saw in the first video using this bar and these edge clamps. That was the main driving reason behind doing it that way. And in reality, I got a little extra support from this bar because I could use that cant twist clamps on the end of the bar as well. So it may not have been all that bad. But now I face this, I'm going to flip this piece of plate over, but I'm going to drill some holes, and I want to intersect these T-slots in this pallet base, and it's not perfectly on center, so I'm going to indicate and set my x-axis 0 center line here, because that's the way I put it in the CAM software. So let me get the dial indicator on here. Now I could probe this probably, and that probably would work, but it's going to be just as easy to indicate it, I think, as far as this goes. It might be a good little exercise to show indicating something like this as well. So let me get the indicator up here close. And I've sort of guessed on the x-axis 0 here. Okay, there's my 0 point. Found the 0 on one side of the T-slot. Now we're going to rotate around. I think you guys can see that now. Let's see if I guess sort of close here. Kind of remembered what the old 0 was. Pretty close. That would have been perfectly fine for what I'm doing here, but it's just this will make it perfect. Okay, we're going to set our X0 there. Let's look at the probing macro that we're going to probe. After I bring the part back in, I'm going to flip the plate over on the fixture, clamp it, bring it back in, and this is the macros we're going to use. We've already set the X, so we're not going to change the X. I'm just going to center the stock on the pallet base with a tape measure, and that'll be close enough because there's about 1/8 of an inch of stock on either end to work with, so that'll be fine. But we got to probe the Y, and this is the Y's probing cycle. G65 again is calling a macro out of the controls memory, and P9023 is the Renishaw Easy Set macro that happens to be in this control. You have to have that in the memory of the controller. It'll give you an alarm if you do this. S1 is the first fixture offset, which is G54. A4 point is an outside web measurements cycle in the Renishaw Easy Set cycle. And the height of the stock is 14.75. And we're going to go down 3/4 of an inch from where the probe is setting at the beginning of the cycle in an incremental move. So that's going to give us the 0 point of the center line of the plate, basically. And then we're going to set this Z by G65, the same cycle, same fixture offset. A9 point is the measurement straight down in Z to set the Z offset. And then we're going to do set that in another 30 thousandths manually by setting it on the offset, subtracting another, or going minus 30 thousandths more on the offset. All right, I'm going to hit it down a little bit more. It's because it's more solidly held when it's clamped in the pallet. I'm going to jog it manually down to the close to the part. Within a distance so that when it goes down 3/4 of an inch, it's going to catch these edges. Now I've got to center it roughly. A little bit hard to visualize the center on bigger parts like this, so what did I say, 14 3/4, so 7 3/8. Around about there is the center. Now we're going to run the probing cycles. Alright, that was the Y. Now I'm going to run the Z one. I put MOs between each one of these cycles so that I have a chance to jog the machine around or somewhere else if I want to. In this case, I didn't need to. So there's the Z set. There's a return. I had a question about this on the previous video, so I'm going to show a little bit about this more. Up here on the, I don't know if you can see it with the lights, but this thing right here is an infrared or ultraviolet, I don't know. It's a light transceiver that connects with this probe here. So when the probe comes into the spindle, you can see this little light. I don't know if you can see it, it's flashing green. If the probe is triggered, see how that goes red when it triggers. So that transceiver is connecting. There's sensors all around this probe. You can kind of see them here, and they sense the light from that transceiver up above, and it communicates with this probe when it's in the spindle. But the way this is set up, all the time this is in the spindle, it turns this probe on the minute it comes in the spindle, and when it's out in the tool magazine beyond that door over there, it can't receive the light signal from the transceiver, so it shuts off after a period of time. I don't remember the interval, but it'll shut off automatically by itself. So it's important that I change this out of the spindle. I don't just fiddle around here and doing stuff, because it runs the battery down faster. This probe takes a 9-volt, just a regular 9-volt battery that goes in here. And I usually put a lithium battery in so that it lasts longer. But there's no sense in just leaving it in the spindle. If I left it overnight like this, it would run the battery down. So here again, we're going to go to the offset. We're going to set this in the incremental mode, Shift I. Down here, input, so that shifted over to the incremental mode right there, and then we're going to go to offset number 43 right here on G54. So down here we're going to enter 43, and we're going to go minus 0.030. It's going to set it in 30 thousandths more, so you should see this number change to minus 30 thousandths more. All right, I had this question on one of the earlier videos, how I got the T-nuts in here. See, I taped a magnet on the end of this small piece of all-thread rod actually, and I can lower it down in here. Heads lined up, and then I can stick this in here like that. Okay, see, I was trying to run it without coolant. I didn't think it was going to last very long. I'm going to have to dig this out of here, and I'm going to have to turn the coolant on to finish this. See if I can get it out. don't know. Might have gone too far with this. See, the problem is with aluminum is it loads up the tool like this. It welds itself onto the flutes. You can't, wow, see, that's hot too. You can't run it without coolant. I could run steel like this without coolant, but aluminum, really can't do it. I'm gonna have to jog the machine out and clear that off, and then we're gonna have to go back with coolant. I was able to get that out of the flute. Fortunately, sometimes that stuff gets welded in there so strong you can't clear it out, but it came out pretty easy. Now jog the machine back down to where I left off, and I'm gonna have to turn the coolant on. And here we go. I was hoping I could run that without coolant so you could see better, but it's not going to be that way. I've got to move the camera back, otherwise you're not going to see anything at all with the coolant on. So I need to run those spring passes just to make sure I didn't have any push off on the end mill, because this is a 5/8 flute end mill here, and it's cutting 2 inches. This is 2 inches thick, the plate. Right now the plate is thicker than I need it, and this is all the milling I'm going to do on the horizontal mill on this piece actually. And then when I get it over on the Mazak and I make the 2 end pieces and bolt it all together, I'm going to machine it to the proper thickness. 0.187 below center line, because the part is actually 3/8 of an inch thick. So, and it wants to be centered on center of rotation. So I'm going to machine these end pieces so it stands up a little bit higher than that, so I can skim the top face over there on the Mazak. So like I said, this part is finished as far as the horizontal milling is concerned. Let me check the other end of that. Whenever you walk around in a horizontal mill, you got to be ultra careful. If you got a tool in the spindle, you can cut yourself bad. On here, you don't have that problem so much on a vertical mill because the tool is up above you, but when the tool's down here like this on a horizontal mill, you can hurt yourself. You got, especially if you slip in there, something, and you grab for something and you grab onto that tool, you got to be careful about that. bit of surface tension holding that on there. From the coolant, I guess. Okay. All right, one part closer to the finished fixture. Although the part's not complete, of course, but it's complete as far as the horizontal mill goes. So we got these two edge stiffeners, some clamp pieces that have to be finished yet, a hole drilled in them, and this piece is for the horizontal mill's fixture, and these are two setup pieces of material for the actual parts. So that's it for right now. Thanks for watching.